Well, Khalilov has authored over 60, yes, 60. He is a professional zero-day hunter, and he's here to share some of his secrets. His talk is Zero-Day Hunting with AFL-Fuzz, uncovering vulnerabilities in open source software. He's going to show us how the pros really do fuzzing. It's not just about throwing random data at things. He'll show us how to be smarter by using powerful techniques and tools to find those deeper, hidden vulnerabilities. And the best part? He's going to show us how it all works with a live demo using SQLite. You don't want to miss this. Please give a massive welcome to Khalilov.
Okay. By the way, can you hear me well? So I'm gonna be a bit too early, but it's okay. I think we have a plenty of demo and presentation. My name is Khalilov, so I kind of mainly do nowadays a bit of a research, but I came myself from red teaming and pen testing background. So I also kind of author a bit of GitHub projects. I did develop like hacking tools like, I don't know, 9 years ago, but I'm not doing that anymore. So today's main talk is going to be a little bit about the vulnerability research. Previously, we had a very good talks on fuzzing using the AFL-Fuzz, and we had a good talk right now as well on different type of threats and vulnerabilities. Whether it's going to be on the bug bounty program or just independently, it's up to you. But today's agenda mainly is going to be about what's a threat, right? What's the vulnerability? And how actually we're going to identify what we want to fuzz or find the vulnerabilities, because there are a vast amount of applications. So we're going to look at it and kind of narrow down what we want to target. And then we're going to look at the life cycle, how we do the vulnerability research, way to start, how to identify your attack surfaces, and do the fuzzing. So yeah, I think it's better I look at it here. And one of the key things here is that we're going to take one application. Unfortunately, I cannot show every full walkthrough because it's going to be live applications, which is on GitHub. We're going to look at the IoT library. We're going to look at Modbus and then MQT broker, which we're going to fuzz together. And one of them, I'm going to show you the vulnerability which I identified like a few days ago. I cannot show you the full walkthrough and what kind of was the exploit. Put there, not the exploit per se, but input to trigger that heap overflow. But we're going to look at it as a demo. It's a pre-recorded, so. But I got a live server as well. We can look at it too. So objective from this talk is that mainly to do the vulnerability research. Previously, we had this Camo-based vulnerability research, right, on the network-based applications. But it's more like a generic, but you can actually narrow it down to the specific segments yourself. This methodology is something that I learned a lot from internet, but something that I kind of narrowed down to my own suitable case, right? So as it I find a bit easier, so I want to share that with you. And then we're going to look at a way to search the target, because like we said, right, there are many applications, so you're kind of overwhelmed with this way to find. So we're going to look at it as well. And then we're going to do a bit of instrumentation. Instrumentation is that basically getting your application ready for fuzzing and identifying the functions which you want to fuzz. And then we're going to do the demo. So threat is basically anything that's going to have a harm effect on your organization, on your digital assets, right? But normally it can be more than that. But basically threat, we understand what it is. But what about the vulnerability? Vulnerability is basically any unwanted system which can cause a harm through this unpatched issues, right? So it could be a weakness on your code, a weakness on the misconfiguration or access control. Anything that has got a weakness or vulnerability can lead to a threat which can cause an impact, right? That's why we all are in this offensive cybersecurity industry or cybersecurity, where we try to understand and patch and identify these vulnerabilities. So one of them is obviously the bugs, both overflows, exploits, access control, or a lot of IoT devices. So if you look at that vulnerability by types, right? Even now, there are a lot of web application firewalls or whatnot. I'm not going to go into the technology per se because I don't want to talk about it. Just even if you look at it, almost 50% of the vulnerabilities are on the application layer, and the cross-site scripting and SQL injection, simple as that, it's still there, despite the fact you can prevent them through a lot of input validations. But even now, they're kind of making up the majority of the vulnerabilities. But another side of game is that still overflow, both overflow, memory corruption on the C language, which was previously shown on the previous talks, is also kind of making up the biggest chunk of the vulnerability. So it kind of shows you where we are. Now, if you look at the threat and vulnerabilities, you have got a lot of aspects, a lot of entry points to this threats, to create this threats, right? Whether it's going to be the outdated software, logical attacks, network-based vulnerabilities, data corruption, memory corruption. There are plenty of them. But here, we're going to look mainly on buffer overflow, on memory corruption, which can lead to zero-day, right? Here, we're not going to be talking about exploiting, because exploiting the vulnerability is another game on its own, because vulnerability research and actually identifying the vulnerability, it's a different thing. So you have got the vulnerability research, triaging, and exploitation. So we're going to look at the life cycle shortly. So let's have a quick look at the statistics, right? If you look at it, before, obviously, yes, our spectrum of the vulnerabilities by type is increasing every year. If you look at it, it's never going to stop. It's not easy, because every year new applications are being developed, and you have got more attack surfaces, and so on and so forth. But if you look at this whole, it's actually took this data from CV database, I think just the last week or so. But if you look at it, right, almost half of it, is majority of the vulnerabilities are on the risk level 7 and above, because CV, they give a score top as 10, and if you look at it, as majority of the attacks are above 7. It kind of indicates that critical vulnerabilities still exist, despite the fact a lot of compilers, a lot of defending solutions out there, they're still not working, because they still can find a way around it. Now, if you look at it from 2015, again, it's taken from the CVEs statistics, right? Because they publish what they receive, because there are a lot of vulnerabilities are actually 0 days and end days, because they're not given to CV database, right? So a lot of the things maybe you don't see, but it's kind of a apple-to-apple comparison, so it's fine. So if you look at it, memory corruption and overflow attacks, if you look at it, every year it keeps increasing, but yes, on the 2023, 2024, they didn't increase, maybe because there was some smart development, but overall, in general, it's still on a big rise. It's not stopping. Now, this executing the code and gain privileges, why I put the executing the code and gain privileges, right? Because if you look at it, overflow and memory corruption, one of the main trigger point for whether it's going to be the black hats or good guys, vulnerable to researchers. One of the key things for the memory corruption and heap overflow, any kind of overflow on the system, is that to execute the code and access to the machine. Even when was this? A few years back, there was a vulnerability on SSH edit, right? Which actually led to privilege escalation, because one of the main reasons for the attackers was that to do the privilege escalations or gain access to the machine. These both are related to each other. So if you look at it, executing the code and gain privileges are also kind of slightly reducing, but going forward, at some point the attackers are going to find a way to bypass a lot of mechanism, whether it's going to be the DAP or annex bits, right? As a lot of prevention mechanisms are there, and a lot of canaries are being, difficult canaries are being placed on the compilers. But at some point they're going to be bypassed. Now, it's not really a quiz, but just to give you an idea, right? A piece of code which actually says that, hey, as quite of printf vulnerability, and then format string vulnerability, or whether it's going to be the heap overflow vulnerability. This piece of code is just very small, but imagine the C library, which got thousands and millions of lines of code, and sometimes the developers are working in groups. They don't actually pay attention to the specific functions, and sometimes they just forget how to eliminate and terminate the user strings. And that actually can lead to the vulnerability of the application. And sometimes it's difficult to identify because during the development stage, for the people, it's about functioning application, unfortunately. It's not about security. So the common questions when a lot of people kind of come to do the vulnerability research is that how to choose a target, where to choose a target, what I'm going to fuzz, where I'm going to get myself a name so that I can say that I found the vulnerability. That's something that we need to actually answer. And then obviously people ask, what kind of way to get those applications, right? Whether it's going to be, previously I think we had the TP-Link wireless router. Yes, the firmware is accessible on the machine, but before you could download them online, and you can download a lot of them nowadays as well. It's just about way to find them. And then how to find the right inputs. Because if you don't have the right way to parse this application, then it's just going to be a waste of your time, majority of the time. So then, yes, and then we had the case previously of writing a wrapper, right? Because sometimes actually creating a wrapper, because you don't have the interaction with the application directly, but you need to simulate it. So it's one of the key things is that to create a wrapper for that. So this kind of questions we're going to answer. So as usual, lifecycle starts with the target selection. It could be your products, library, protocols, firmware, like we've seen before, or like we've seen, well, like we're going to look at right now, later. It's a library, which we're going to actually fuzz and identify the vulnerability. But it could be a lot of things. So the target selection could be from trial version of the application or open source applications or black box, because not everything you have got the access to the source code. Then one of the key things, like for anything to hack, is that understanding what you're dealing with, because if you don't know what you're dealing with, you don't know what's going to be the attack surface, right? It's one of the key things is that doing the reconnaissance, understand how actually the application expects the user's interaction, what kind of files, formats, or parsing it's going to take. So one of the key things is that for you to understand that. You can read the manuals, you can read online, you can just look at what other people, because nowadays it's just internet is huge, right? You can actually get the protocols and then file formats online easily. Another thing is that enumeration. Once you have got this application and how it actually interacts, understanding its flags, features, functions, access control, privileges, that's one of the key things is part of the reconnaissance, but enumeration is one of the key things as well, so that you have got a visibility how to reach those specific targets. We're going to look at the target selections later, but this is going to play a critical role. Yeah, it's interface selection is basically the same goes as enumeration. It's basically if you're going to target, is your application taking the user inputs through the command line as a flag, or if it's parsing the file, or if it's actually looking at the network interface to parse them, for example, TCP dump, right? So you need to understand what's going to be the attack surface. Then once you have got those things in hand, you understand your application, corpus creation is one of the key things, because you cannot blindly give your application something it doesn't handle, right? If your application is handling, let's say, XML parsing, you cannot so easily give it just a text format, right? Because it doesn't have the necessary flags or necessary brackets or necessary tags to look at the file, because it's going to treat it as unaccepted file, and it's not going to reach the specific functions of your application. So that's why understanding your application and creating the corpus is very important. I think previously on the Netgear, researcher was doing the fuzzing through the GET request on the application. So that's one of the good things, right? Because he knows what the server or the Netgear router is expecting, and that was it was fed into the application. Understanding what you're feeding it to, it's very important. Once you have got what you're going to give it as an input, right? Whether, for example, I remember the time when I created the wrapper for the libpcap on TCP dump, right? one of the key things was that for me to identify what kind of capture file I'm going to give it. So I think at that time I gave it a Cisco OSPF protocol pickup file to do the fuzzing, and I think I found the vulnerability at that time. It was some time back, like 6 years ago. Now it's not that easy. But understanding that is very important. Once we fuzz it, you also got the kind of key thing is that how you're going to fuzz it. So today we're going to look at the AFL-Fuzz, which was used today on chemo simulation. But we're going to look at this AFL again, but you can choose any other kind of fuzzing tools, whether it's going to be the AFL or some Python script or Domato for the browser. It's just the approach remains the same. And then key thing is also to monitor. We're going to look at how you do the monitoring as well. So once you have got a vulnerability, not every vulnerability or crash which you see on your AFL-Fuzz or on your processor, it doesn't mean it's a vulnerability on its own, because some of the applications, what they do is that when the application crashes, it doesn't mean it's exploitable. It doesn't mean you can control the process execution, right? Because if you really want to exploit something, you need to be able to redirect the input to somewhere else, right? The instruction to some command. But a lot of the time, application, they're going to abort it. They're saying that, hey, this shouldn't happen, I'm going to abort it. Or it could be just integer overflow, which is not so easily exploitable nowadays, right? So you need to try it because you're going to have thousands and thousands of crashes. And for you to automate and identify where's the vulnerability, and if this crash is exploitable, it's one of the key things, because you need to look at the processors if they're actually overwriting the right registers or not. So after the triaging, it's obviously it's up to you. It's majority of us, we do the reporting. So you need to write a good report for that vulnerability and provide this information to the vendor who's managing this library or application, and then report it to the CVE emitter, right, to obtain the CVE. But normally nowadays the vendors themselves, they provide you the CVE number, which you can actually give to the CVE database, or the vendors themselves can actually handle everything on your behalf. Now, once you write the report, and after you have got like 3 months or so to wait for you to actually write the POC exploit or working exploit, I think for me it was like, there was some vulnerability I want to put for, I hope nobody's from F5, but it was like 11 years ago. For that product, I had to write the exploit, but it took me like 1 year or so before I could publish it. So it takes a bit of time. Now, we're going to look, in one of the demos, we're going to look at the MQT broker, right? It's mainly, we have got 2 demos. We have got actually 3 demos. Not all of them I would be able to show you because we don't have time. You can always reach out to me. I can give you the link to the video and this guides I have created. But we're going to look at the Mosquito, which is MQT broker for IoT devices. And then we're going to look at the Modbus, which we can fuzz together. I mean, we're going to look at the video, but if I have time, I can show you the server as well, which I'm running at and fuzzing on that place. We can look at it live as well. So, for example, for the Mosquito, it's a big C-based code, right? One of the key things is that for you to identify and do the reconnaissance is that does it contain the vulnerable functions, if it's using it or not, right? So I normally go with the grep. It's easy, but you can go, it's quite a lot of tools. But it doesn't mean grep is going to give you always correct results. It might say that, hey, yes, it got some print vulnerable functions, or it got some string copy without validation of the inputs, but it's not always exploitable. It takes a bit more time, but it gives you an idea where to start. And then I'm also here using the semgrep, because semgrep is, I think, one of the good tools for you to have a quick static analysis of the source code and see if it has got a vulnerable function. So it's free as well, right? So why not? Yeah. It doesn't mean that free is bad, but you can actually increase this semgrep's functionalities with improved detection. So once you have got all this information, just one of the examples, what I do is that I think I did use it for one of the audio encoders long time back. I put it here just as a sample. Just look at the manual interface, what kind of flags it takes, right? What kind of file format it takes. If it takes like playlist, MP3 or whatnot, and just take it from there. It's one of your attack surfaces. But if you look at the attack surfaces, majority of the application, if you look at online, right, majority of the attacks are happening because something is taking the wrong parsing of the application, whether it's going to be the XML file or file format. It's all majority of it is because of parsing or user input validation, the length, the format. It's not properly being terminated, handled, and formatted, right? And obviously, you have got other parameters, for example, from the operating system, system calls, and some other ways. One way or another, you need to be able to interact with the application. Without it, it's just not possible for you to trigger that specific function. Yeah, it's another way I take is that just Wireshark, which I did for LippyCap at that time. So now where I'm going to find the vulnerabilities, right? So you can use on Linux, you can use apt-cache search, you can say apt-cache search parser. It's going to give you a kind of an overview of what kind of libraries out there, but you can also use Google Dorking, and nowadays you can use ChatGPT or whatnot, right? So there's quite a lot of ways for you to gather that kind of information. So when you're doing the vulnerability research, we're going to look at mainly the three aspects. We kind of briefly looked at the static analysis using the samgrep and grep, right? But there are also tools out there, which is paid versions, which I don't normally use since nobody pays for this always, right? So we don't use that. But there are a lot of tools there. I'm not going to say out loud their names. And then, yes, fuzzing. Fuzzing is actually a very effective way to identify the vulnerabilities, and you can easily replicate on different applications as well, as long as you can instrument it and provide the right corpus. It takes a bit more time, but it doesn't take as much time as concolic execution, where you combine the symbolic execution and static data together, because concolic execution is a little bit more complicated to set up because it takes a little bit different approach, but we're going to look at it later. But static analysis and fuzzing is, I think, one of the easier way for you to identify and find the vulnerability. So some of them is just AFL-Fuzz and then HongFuzz and LeapFuzz. There are quite a lot of them you can use. You can also develop your own Python, which is really good, and you can be very, very precise on Python as well if you know exactly what you're looking at. And for concolic, there's something called solution modifiability theorem or satisfiability module theorem, right, from Z3 from Microsoft. You can use that to actually identify the constraints on the application and create the new corpuses. But we're going to look at it later. But it's basically telling you, creating a map, for example, to the shop, which you don't know, but it's actually trying to do that for you. That's how you will be able to trigger those functions. I'm going to show you later why it's very important to do that. So before, previously, it was explained what's fuzzing. It's fuzzing basically taking something from you, modify it a little bit, and push it back into the application, see if it crashes or not. If it doesn't crash, it's going to keep going and modifying the application, and then it keeps going on forever until at some point you're going to stop it yourself, right? But fuzzing is basically keep going through the content which you provided, which we call it as a corpus, right? Modify it, push it back into the application until it's going to say that, you know what, I cannot handle it, this is the error, and based on that, you're going to keep working on that error, see if you can further exploit it. It can be very fast. It can be smart based on what you're going to do it. But one of the things that you should not be mistaken is that fuzzing is not going to find you all the vulnerabilities. It's going to find you maybe shallow vulnerabilities, but it's not going to give you the attacks which can be exploited through the logics or which can be actually exploited through some sort of a access control or authorization bypass, right? Because that's something you should be aware. It finds mainly the crashes, not something that it takes a logic and some access control. So what kind of bugs normally is fuzzing is going to find is it's majority of the time it's something to do with memory, whereas your CPU, your processor cannot handle, because pretty much all the operating systems, they have got a kind of a trigger or abortion if certain application is not handling the error properly. Even right now, for pretty much all the Linux users now, if the application doesn't work, they can just go echo and with a question mark, it's going to tell you if the application is executed successfully or not, right? Or they can just look at the kernel messages, sometimes for the kernel-based errors, to identify if it was executed properly or not. Because in operating system, everything is written somewhere. But logical errors, obviously, no. I'll just give you one of the example. We had, it's from not for fuzzing, it was for pen testing. We had a banking application which we had to test. Obviously, vulnerability assessment is part of it. But during the assessment, right, you actually, during the transfer of money, if you just, it was a long time back, nowadays you don't find it a lot, but if you put the minus before that sum, it actually adds the money to the originating account. So you would end up having a money deducted, you actually end up having more money in your account. So it was like a minus and minus in computer science, or in mathematics, it's like plus, right? So it had a very, very silly mistake. So yes, overall, fuzzing, it can find majority of the time memory corruption and race conditions and null dereference, heap overflow, but it's not going to find you some very critical logic-based attacks. So the type of fuzzing, I mean, I'm not going to go too much deep into this, but that's a kind of a dumb fuzzing and the smart fuzzing, right? Smart fuzzing is for you to actually understand what you're feeding the information to, like we took an example of XML parser or XML library that you want to parse, and then you, for the XML, when it's expecting XML, you give it some TXT file, till it's going to generate that XML format. It takes you maybe very, very long time. So it's better to be smart and give the right content, and maybe you can use Radamsa. I don't know, I think people here use Radamsa or not yet, I don't know. It's a very old tool, but you can configure Radamsa as well to create the right corpus. So it depends on you, right? So you got to be a bit more clever with your fuzzing because you don't want to waste your time. And yeah, there's a mutation and generation-based fuzzing. I used for the generation pitch fuzzer on Windows. It's right now it's a little bit expensive, but you can use the community version as well. But it's a little bit more complicated to create your own XML. So now, when we talked a little bit earlier, right, about you should be able to read the function code properly and provide the right input. Why is that? Because application is basically taking input from you, and one of the core concepts of every application is that work based on the condition. If it's true, I'll go here. If it's not true, I'll go there, right? So when you give some sort of a content, based on the content, if it's XML, it says that, okay, let me reach here to parse, go to another function. And it goes to that function, and there's some sort of a inline processing there going on. It's going to take another function, so on and so forth. It's going to try to find a path within the application and go to different segments of the code. But if you give it very dumb data, it's just going to exit after one function block. So giving a right content, you're actually triggering more and more function and more coverage. That's why your function coverage is very important. If you have time, we're going to look at it. There's a LLVM projects, right, with CLang. You can create your coverage, and I understand before you start fuzzing if it's actually covering majority of the functions or not. Now, we talked about the fuzzing, right? Majority of the time, when we provide some corpus, it's basically a concrete value we provide as an input, right? But this concrete value is, let's take an example of going to the big super mall, right? It's a one-story mall. It got very many different aisles. And you have got a map to say that you go to this entrance, turn left, turn right, turn left, and you got the milk. And you don't know anywhere else where to go. So it's kind of a map you have, and you don't have anything else somewhere else. Now, symbolic value is that, let's say you go to the theme park, right? Like Disneyland or whatnot, and then you say, hey, there might be a condition. I want some places they accept the entrance is that, hey, you need to be older than 14 years old, you got to be at least 1.6 meters, right? And then you should be of different categories. Before they kind of got a criteria for you to enter. So symbolic execution is basically going to try to solve the constraints by eliminating and identifying which paths accept what kind of conditions and create the corpus based on that. And this corpus, you're going to add it to your concrete fuzzing, which is, in a sense, going to create the concolic execution of your fuzzing. It's going to combine both a symbolic execution and concrete execution and create this dynamic environment for you to fuzz from both sides. Now, we just give an example of the Maze Explorer. So I just want to make sure that we're on time. So it's like, yeah, so I kind of got a park theme, right? So we have got a fuzzing engine and symbolic executions, they work hand in hand together if you properly implement it here. I have got in one of my demos, I have implemented CLI as creating the symbolic execution as well as NGR and Python. I don't know how we're gonna pronounce it, but NGR is one of the great ways to create these corpuses. And then once you create it, right, you have got a QCM, SymCC, and CLI to create these functions. And these solutions, this QCM and SymCC and CLI, they work with Z3, which is constraint solvers. They're going to actually identify with the symbolic data some new corpuses and then create these corpuses back and feed it back into the fuzzing engines. This is basically, if you gave it 2 XML files, it's going to generate 100 more based on that your initial input, right? So that's how it works. Now, what's AFL? We already talked about it, AFL before. AFL is one of the fuzzing softwares, right? But if you don't use it properly, it's just going to become a bit of a waste. I have 5 minutes? Oh, okay. Sorry. I thought I'm going to have a bit more time. But you know, I'm going to be here. We can talk a little bit more. But let me show you a little bit of a demo. So Mosquito, unfortunately, we had a bit of a... Yeah, 15 minutes? Okay, sure. No problems. Sorry, guys. I think we got a bit excited here. So now we can go a bit slower pace. Okay, sorry about that. So we looked at the AFL, right? I'm not going to go into AFL again, so let's not waste our time here. So basically, AFL is a tool. It takes the input, modifies it, and feeds back into some application, and look at the processor and see if it's going to crash or not. If it's going to crash, hey, I'm going to put it back into the queue, and then I'm going to modify it, and let me try to trigger something else. Otherwise, I'm going to keep modifying the application, the corpus. Corpus is basically, by the way, corpus is an input which you're going to feed into the application, right? For example, TCP dump is going to take a pickup file. So pickup file is going to become your corpus, just to make sure that we are on the same page. So that's basically what AFL does. It takes the input, feeds it into the application, look at the processor. If it crashed, hey, I found a crash. If it didn't crash, I'm going to go and keep modifying it till I find a crash. So the logic and the kind of algorithm works like on the screen. It kind of keeps repeating it in the loop. So it's like a while loop until you can, until you press the Control-C button. So AFL layout is straightforward, so I'm not going to go and read it out for you. Instead, here I got a bit of a overview how it looks like. We're going to look at the screen as well. So it's basically, it's going to tell you, I wonder if I can show here. So here is like saying that, hey, I found the 14 crashes, and here it says I have got 2,000 plus crashes, right? Why showing you 14 unique crashes here and then 2,000 crashes here? Because AFL itself, it knows that these 2,000 crashes are not unique, because it's actually triggered on the same place by different type of inputs, right? So that's why it's saying that I got 14 crashes, but you also should know that these 14 crashes are not also exploitable. So I also need to actually get the expectation straight here as well. And here, it also shows the execution speed is like 4,000 plus execution, how many? Yeah, 1,000 plus execution per second. It kind of keeps telling you how long it's been running, and it's going to tell you the depth of the analysis and coverage of the application. But keep in mind, coverage of the application is going to keep changing as it's going to find more and more functions. So I'm not also going to go into the installation part, because installation is very straightforward. There are a lot of GitHub online tutorials, so let me not waste time here as well. So yes, now when you're actually compiling the application, let's say you say that I want to go and try to fuzz some libpcap or some sort of a library or some application itself. It's easy. You're going to replace on your Linux your AFL-Fuzz. AFL-GCC is basically the compiler, but in here it's going to compile with inserting AFL its own tracking functions, right, to make sure that every time when some function is executed, it's going to map it in its engine, and it's going to keep mapping the whole application it goes, and it's going to trigger the crash detection if it's going to find some vulnerability. So it's basically you're going to go and configure the application, and then you put your CC, your compilers as AFL-GCC or AFL-CLang, or whatever you have got installed and configured. Treat the AFL as your compiler, okay? And then it's going to do the rest afterwards. I'm going to show you later. And then you just compile your application as it would, but keep in mind AFL-GCC or AFL-Fuzz, because a compiler sometimes is going to cry about your libraries. You got to provide and understand what kind of libraries it's missing. It's like normally, just like CLang, GCC is just capital L, and you provide the folder to the library. Once you compile it, you install it as you normally do, but I would not recommend clicking, I wouldn't recommend go and do the make install, because otherwise you're going to put under your bin, right? So let's not do that. But it's up to you if you want to. Then here, if you can see on the GDB, it's saying that we can verify the application is looking at the, we're looking that AFL function is inserted and instrumented. Before we talk about the instrumenting the application, that's what we talk about. We have got a function ABCD with a jump to E, but here when you instrumented ABCD, and then you're going to put a bit of a function of AFL B2, and then jump to E or something like this. It just makes sure that this function is actually being monitored by this AFL. So again, I'm not going to go with AFL flags. You go, please have a look at it. Why I want to put here is that majority of the time you will have difficulties with the libraries and functions. There's always a flag, there's always a way, and there's an easier way to do it. Sometimes it takes like 2-3 days, when actually the solution is just in your nose. You just need to do the help on the application. So we're gonna quickly look at the mosquito. See if I have it here. Can you see it? Oh, sorry. How can I show this? There you go. We'll have to watch it half screen. Sorry about it. So we actually downloaded the Mosquito. It's a library for the MQT broker. It's recently I kind of decided to look at the IoT and OT-based libraries because they not seem to be looked at a lot. Recently we had red teaming engagement for one of the customers. And then I saw that, hey, it's time maybe, even if the customer is not paying it, it's just understanding that those environments are very weak. So then, yeah, I decided to look at those libraries. So I kind of created a list of what I want to target. So yeah, Mosquito is one of them. It's basically the broker and subscriber between the multiple devices. So I'll try to be quick. Yeah, so we're doing the semgrep and grepping the libraries and the codes, right? Once we identify the function, we're going to be creating on the C code call to the specific vulnerable function, because we know that that's the MQT property seems to be vulnerable, right? And then we're going to create a wrapper on C, which is going to call that specific library and then fuzz that specific segment of the code. And then at the same time, I'm actually creating with CLang LLVM project, under LLVM project with CLang symbolic execution, where I can create multiple inputs with only 1 or 2 inputs, right, which I provide. Then I would be able to create 100 plus different unique inputs, which is going to solve entering the unknown functions. Like I give you an example of the shop. So you go to the milk unit, milk department, but there are a lot of other departments which you don't know. But with that 3 execution, you can actually try to identify approximately where they're located. You're actually expanding your map and then reaching different segments. And then with LLVM, you can also look at the coverage. Once you generate the input, what you can do is that you can insert all the inputs into the application and see if your inputs are triggering the functions or not. This is one of the very good points for you to understand if it's really worth looking and fuzzing with the current input, or you need to actually do a better job in doing the reconnaissance and enumeration. So let me go a bit fast forward. Once we're a bit happy with our input and corpus, right, we're gonna, I normally check to make sure that my input is triggering the function. So I'm gonna go with the GDB or just the NM or some other ways to run with my input and see if it's actually triggering the specific function or not. Here we're just going to go with object dump, or we can just go with GDB. So here I'm running my corpus with GDB onto my wrapper. And this wrapper should be able to trigger that function which I'm interested in, because I feel like that's actually a vulnerable application. For example, break property read all of the Mosquito library. I feel like it's a bit vulnerable, right? So I'm going to look at it. Okay, where's this? Come on. There you go. So here, when I put a breakpoint on the read property, here you can see, yeah, you can see this cursor here as well. Here is actually a breaking point, which is good. Now I can move forward with my fuzzing. So you can also, because one of the things is that majority of the times these libraries, like any execution files, right, there's a magic number. Based on that, it's going to say, hey, it's a PDF file, it's some other files or not. The magic number is good, it's important for any target application to understand what I'm expecting. So here, what I also did is that in AFL-Fuzz, you can create a dictionary. Dictionary is basically a file which contains keywords and the bytes which the application expects to be able to trigger different functions. So this here, I did use ChatGPT to generate this dictionary file for me, because it can just go and let's make use of the AI a bit better, right? It's going to create a dictionary file for me, and then it's going to go, I can just feed it into the application. And then I use the screen mainly because my setup is basically, yes, I got this laptop, but it's not a laptop for fuzzing, right? You need a bit of hardcore laptop. So I got my own server at home, which I'm going to SSH to it normally, and then run my fuzzing on that environment. So I normally use a screen to manage my multiple processors, right? And then I'm going to keep fuzzing it. And then I'm going to come back and check now and then to make sure, see if I got a crash or not. Now, I don't normally go and do that. I do it maybe very rarely. Why? Because I have got my own, I use Slack API to keep notifying me every 1 hour if there's a crash or not, right? Which I'm going to show you shortly as well. So here I create the master and slave mode on the fuzzing. It was mentioned before, which is actually fuzzing right now. It takes a lot of time. I'm not going to show you here exactly because the crash, because I actually showed you from start to finish almost how to fuzz this application, but I'm going to show you another application which is, where's this? Where I got a vulnerability where there's a heap overflow. It's on the Modbus library. If you want, you can go and fuzz it yourself, but I'm not going to show you exactly where this thing exists. Okay, how can I put it? There you go. Okay. Just a moment. So this is exploit. I mean POC exploit. I kind of wrote. I cannot show you the bytes which I used it, and but you can see here clearly. It is basically heap overflow happening. I did verify it manually outside the AFL-Fuzz. This is one of the key things. But here, we're going to look at the vulnerability together. I have got multiple engines here. I'm just going to use one of them. Here, I'm going to pause it. Here you can see the crash is identified. How can I make it bigger here, no? Once I identify the crash, I'm going to go and verify it outside the AFL-Fuzz to make sure that I can trigger it. So I have got 7 or 8 crashes, unique crashes, right? Here the trigger is happening outside the AFL-Fuzz only on the specific library execution. This also with GDP, you will be able to identify exactly which line number is vulnerable. Here I'm just grabbing the specific segment of the code which is vulnerable, which is 1518 before and after the code. Here. So I will not tell you exactly, like I said, the specific byte which led to this vulnerability. I will not be able to tell you exactly the exploit or POC code, but you can go and test it yourself, fuzz it, and then take it from there. Okay, I cannot go any further than this. Now, this is the issues that I want to share with you. It's live. It's still fuzzing as we speak. Now, how are you going to monitor your vulnerabilities, right? It's a bit of not easy every time go and check it, right? We're a bit busy people sometimes doing something else. So I created the SSH script, right, which I put it under the cron job. It's automatically going to check every 1 hour, send me the Slack messages saying that, hey, I still didn't find anything. Hey, I found something. Go and check it again. And then maybe I'm going to go and verify if that POC, if the crash is exploitable, if the crash is legitimate or not. But keep in mind, crash and exploitability, they don't always mean, crash doesn't always mean it's an exploit, but it could be a threat at some point later, right? It's one of the things that I found on the SQLite, but it's fine. I'm not going to talk about it right now, okay? So with the rest of the things about the optimization, we talked, I think previously, we talked about the AFL-Fuzz. Again, I'm not going to go too much in that because I need to give a podium to somebody else. So yeah, otherwise, internet is open there, right? So you could just go and look at the AFL-Fuzz or some other fuzzing techniques. One of the key points, use your RAM, random access memory, to the read and write, because fuzzing is a lot of read and write. Your SSD, hopefully nobody is using the HDD, but SSD is not going to be good for you. Use the RAM, protect it. It's going to be much faster than anything else. So that's pretty much it. Thank you. Any questions? No? So yeah, thank you.